In this module, we'll discuss about different applications of digital signal processing on DSP development board. First application is binary counter. Here the problem statement is design and implement 4-bit binary up counter using DSP development board. Here we are talking about TMS 320 C6748. The counter should increment its value from 0000 to 1111, that is 0 to 15 in decimal, on each clock pulse, and then reset to 0000, repeating the sequence continuously. So the functional requirements are initialize DSP board with GPIO pins, generate clock using delay or timer input, increment a 4-bit variable 0 to 15, output the binary value to 4 GPIO pins, reset counter after reaching 15. Here DSP processor runs the counter program, timer and delay block generates clock pulses, GPIO interface output to external pin, LED display to show the output from 000 to 1111. The algorithm is initialize the DSP system, configure system clock and initialize GPIO pin as output, initialize counter variable to 0, begin infinite loop, output the counter value, send 4-bit value of count to GPIO pins. Each bit corresponds to one LED. Generate display. Use software delay to timer to create visible time gap. Increment the counter by 1. Check this overflow condition, that is, if count is greater than 15, set count equal to 0. Repeat this steps 5 to 8 continuously and stop. This is the GPIO pin write. It will write to this number 45, 10, 110, 109 appropriately from the content of A0, A1, A2, A3, which is modified after this loop. And the delay is added. This is the code for up counter.
This is DSP board TM.
Now waveform generation. The problem statement is design and implement a system to generate continuous waveforms such as sine wave, square wave or triangular wave using DSP development board. The generated waveform should be output through a DSC and observed on an oscilloscope or the monitor. Object is to generate continuous periodic signals using DSP, to interface DSP with DSC, to visualize and analyze generated waveform. Here we will show demonstration of sine wave and triangular wave generation. Algorithm for sine wave generation is initialize DSP system, configure system clock, initialize DSC as usual, initialize waveform parameters, that is sampling frequency, desired signal frequency and amplitude. Then generate lookup table to store the sine wave values by evaluating this equation x of n equal to a sine 2 pi n upon capital N. Then we have to set this index to 0 and then we have to enter into this infinite loop the output samples from x of n to DSC increment this index by 1, and when this limit exceeds this value of n, it has to reset to 0, and we have to maintain this sampling rate. We have to repeat these steps through 7 to 10 repeatedly. So this is the schematic diagram of sine wave generation with the help of AI. Sine wave generated on the screen. Is the code for sine wave generation.
This is DSP board.
Similarly, for RAM generation, this is the schematic diagram generated with the help of AI. This hardware configuration remains the same.
This is DSP board TMS.
Now, real-time audio signal filtering. Real-time means processing happens without noticeable delay. In fact, without storing the sample value, the processing is done very fast. DSP's role is to execute this filtering algorithm efficiently. Basically, DSP hardware implements filtering operation. Now we know we have two types of filter, FIR and IR. FIR is more stable. It has linear phase characteristics. IR is efficient, less computation. It is used in noise reduction, audio equalizer, and echo cancellation. Procedure is audio signal is captured using microphone. It is converted into digital form using analog to digital converter. The DSP processor applies to digital filter. The process signal is converted back to analog signal using DSE, and the output is heard through speaker or headphone. This is the schematic diagram generated with the help of AI. This analog input signal is first given to the analog filter, and then DSP development board filter it, and then analog output filter, the audio output is generated. So this is more detail about this real-time audio filtering using DSP core chip. We are demonstrating real-time audio signal filtering using DSP development board. Now this is DSP development board integrated